Welcome to Advanced Functional Programming. I'm Graham, one of the professors in computer science in Nottingham, and it's going to be my real pleasure to teach you the course. So what I'm going to do today is a couple of things. I'm going to kick things off in the normal way with a brief overview of the module, tell you a bit about how it's structured and what kind of things you're going to be learning. And then we're going to move on to a Haskell refresher. So I expect that many, if not most of you, probably haven't done much Haskell since the first year. So we're going to refresh your memory with a worked example, which I'm going to go through over the first 2 or 3 lectures. In terms of prerequisites for this course, in order to take this module, you must normally already have completed the first year Programming Paradigms module, either with me in Nottingham or at one of our other campuses. If you're a Nottingham student and you haven't done this, maybe you're a mathematics student or a physics student and you would like to take this module, then please do speak to me and I can confirm whether you've got sufficient Haskell knowledge in order to be able to take it. For the computer science students in Nottingham, I generally advise that in order to take this module, your first year average should be about 65 or maybe 70%. It is an advanced course. It does build upon what I taught you in the first year. We will be looking at some more sophisticated concepts. So generally, in order to take this module as a second year computer science student in Nottingham, I would recommend you have a first year average of about 65 to 70%. So in terms of practicalities, there's going to be 2 one-hour lectures per week. And further details about these are available on the module's webpage. And in particular, there you can find when each of the lectures are, where they are, and what we're going to be covering each week. There's also going to be some labs. So we're going to have 1 2-hour lab session per week. And these will start once the first coursework has been handed out. And the idea is that these labs are basically designed to help you with the coursework. So I will be in each of the labs along with 2 or 3 PhD students who are also expert on Haskell, and we can help you with any questions about your coursework or anything else to do with the module. So again, the labs will start in about 1 or 2 weeks' time once I have handed out the first coursework. In terms of lecture notes, the lectures will mostly be given using a tablet, in fact using an iPad. So this is an old school kind of course. If you took the first year Haskell course with me, most of the teaching I did was using PowerPoints. So in the second year Advanced Functional Programming course, I'm mostly going to be teaching using an iPad in an old school kind of chalk and talk style. I do, however, recommend that you still take your own notes or make your own notes. The students who tend to do very well in this course take what I teach them in the iPad lectures and kind of form their own study notes from those. So if you want to do well, I suggest you do that too. I'm also going to provide you with some extra material on the module webpage. And what I'm going to put there is any slides which I have. So I've got a few slides, just these ones here basically. So I'll put these on the webpage as well. I'll put the Sudoku code, which we're going to be developing over the next few classes. I'll put that onto the webpage as well. And we're also going to be covering material from 2 or 3 chapters of my Haskell book, and I will give you copies of those chapters on the webpage as well. In terms of a textbook for the course, there's in fact no required book because I'm going to give you the chapters from my own Haskell book that you need in order to take the course. But if you did wish to do some additional background reading or take your Haskell knowledge a bit further, then you may want to have a look at this. But again, I don't require that you have access to this book for the course because I'm giving you everything that you need on the module webpage. In terms of assessment, there's going to be 2 programming courseworks and 1 written exam. So the first coursework is going to count for 10%, and I'm going to ask you to write a simple Connect 4 solver using game trees. And it doesn't matter if you don't know anything about game trees because I'm going to tell you everything you need to know in a kind of briefing lecture about the first coursework. The second coursework is going to count for 15%, and it will be to implement a simple compiler using the state monad, which we will learn about later on in the course. And again, it doesn't matter if you don't already know anything about compilers, because I will give you a briefing lecture which explains everything you need to know in order to do this coursework. At the end of the course, there will also be a written examination which will count for 75%. And I'll give you more information about this towards the end of the course. In addition to the formal courseworks, there will also be some informal, non-assessed exercises. And this is the same kind of thing that I did with you in the first year. Most of my classes in the first year ended with a few exercises, and you could try those in your own time. Many of the lectures which I give you in this advanced course will also suggest to you a number of exercises which you may wish to do. So again, if you wish to do particularly well in this course, I would recommend that you have a go at all of these exercises. And if you have any questions about any of these, then you can ask us about those in the weekly lab sessions. To wrap our overview up, I'd like to tell you a bit about the actual module itself. So we've got 2 bullet points on the slide here. So the first one says, functional languages represent the leading edge of programming language design and the primary setting in which new programming concepts are introduced and studied. So this is quite a bold statement. You might say, what's my evidence for this? So my evidence for this is the POPL conference. So POPL stands for Principles of Programming Languages, and it's the main programming language conference in the world. It's been running for many, many years. And if you look at this conference these days, many, if not most, of the research papers, which represent the cutting edge of programming language work, these are about functional programming in some way. So what this module is going to do is it's going to build on the introductory Haskell course which I taught you in the first year by focusing on a number of more advanced topics in functional programming, including aspects of recent and current research. So in terms of topics which we're going to be covering, these will vary a bit from year to year, but will typically include the kind of topics which I've listed in the bullet points here. So the first of these, programming with effects, is what we're going to be focusing on in the first half of the course. And this is the magic monad word, which I probably mentioned 1 or 2 times in the first year in passing, but didn't really draw it out as a concept, and we didn't look into the details of it because it's a more advanced concept. So we're going to spend the first half of the course thinking about how to do programming with effects using the monadic features of Haskell. The second half of the course is going to be focused on reasoning about programs, and what I mean by this is doing proofs about your programs. So this is something we didn't really touch upon in the first year course. There I taught you how to write simple Haskell programs, but we didn't see how to reason about them. So the second half of the course is going to be about reasoning or doing proofs about your programs. And this brings us on to the third topic, improving program efficiency. Something we're going to find, which is quite strange when you first see it, is that thinking about reasoning about your programs can also help you to improve their efficiency. There's quite a close link between doing proofs and improving the efficiency of your programs. So I'm going to teach you about that as part of the second half of the course as well. And again, as I mentioned, some of the things that we'll be covering in the course will include recent and ongoing research. So what I'm going to do to begin the actual course itself is we're going to be focusing on an extended programming example to refresh your Haskell knowledge. And what we're going to be doing is looking how to implement over the next 2 or 3 classes a solver for Sudoku puzzles.